Hi everybody, welcome to lesson 5.2 where we're going to talk about rates and unit rates. So we'll work to understand what those are, how we calculate them, and also we're going to talk a little bit about equivalent rates. So let's take a couple minutes and talk about a couple things with terminology here, okay? So first one is rate. So a rate is a ratio of two quantities using different units. And when we introduced chapter 5, I talked about that a little bit. It's comparing things like miles and gallons of gas that you use, or the cost of something and a measurement for something. Things that are not normally put together, they're very unrelated to each other. It's usually what we think of when we talk about rates. But when we put them together as a rate, they kind of make sense together. All right, then we have unit rates. Okay, so that compares a quantity of something to 1 unit of another quantity. And that 1 unit, that's important because that's our second thing in our rate. Remember when we talked about our ratios, we had our first item and our second item? Well, when we talk about our unit rates, our second item is going to be 1 unit of that. Then we have equivalent rates, and you guys, I know you know what equivalent means. We talked about it a bunch. So, equivalent rates are rates that are equal to each other. We could get them all simplified to the same unit rate. Okay? Now, a rate, we can write them just like we wrote our ratios. A unit, so A just represents something. A units of something, colon, B units of something. You could also use the word to. We could also, when we think of its value, remember when it's in the fraction form, it's its value, we can write it as a fraction A over B. Now, look carefully at how we write our rate, and then how things are related to each other when we get to our unit rate over here. I'm going to step over here. So our unit rate, we can write it as A over B units. So that first over second item amount of units compared to 1 unit of that second item. So you've got the 2 different colors to try to help distinguish that. Or if you write it as a fraction, it's A over B all over 1. In our fraction, in a unit rate, the denominator is 1 for that unit rate. All right. Now I'll write that there. Denominator, a fraction, is 1. So something, hopefully that helps you remember that as you're looking at what a unit rate is. Now we'll take a look at a few examples. Okay, so now I'm back with a couple examples. But as we think about our unit rates and unit rates in general, we need to think about what order we need to write the items in as we're comparing them. What makes sense? Sometimes it might even be helpful to say it out loud. Now, a couple things to think about. Cost, the cost of something is usually one of the first items, and time is usually one of the second items, okay? Doesn't have to be that 100% of the time, but as you're trying to get an idea of what's going to work and how to set things up, keep that in mind. Distances, other measurements, it just depends on the context. If there's really nothing that gives you any clue one way or the other, then just like the ratios, go in the order that it's written, okay? All right, so let's think about this one. You run 50 meters in 10 seconds, so we want to find the unit rate. So does it make more sense to do meters per second or seconds per meter? Yeah, I suppose you can make an argument one way or the other, but most of the time we talk about how fast do you run? I run this distance in this amount of time. So the distance is first, the time is second. All right, so let's set it up that way. Let's write our rate. Our rate will be 50 meters. And I put the units in there just to kind of remind us what we're talking about, but we're going to focus on the numbers. So this is our rate right here, 50 meters in 10 seconds. I like to write it as a fraction. Could you just write it with a colon or a 2? Absolutely, you could. Okay, that's our rate. Now, we said our unit rate always has a denominator of 1. So we want to figure out in 1 second, how many meters do we travel? Well, what do you have to do to 10 to get to 1? You have to divide by 10. That's right. Pretty sure I heard you guys all just saying that out loud right now. We divide by 10. Now, if I would divide by 10 down here in the bottom of my fraction, what do you think I'm going to have to do up on top to get an equivalent fraction? Because equivalent fractions, equivalent rates, equivalent ratios, all that kind of stuff, all related. Well, that's right. We're going to divide by 10. 50 divided by 10 then is 5. So you run 5 meters in 1 second. And remember, previously on the board, I had written that that unit rate was A units over B units, colon 1. Well, if we wrote it that way just for a second, I could write 50 over 10 colon 1. Well, what's 50 over 10 reduced to? 5 to 1. Same thing. Okay. This, by the way, here is our unit rate. So hopefully you're seeing some of those connections there of what we're doing. All right, let's look at the one down here. 240 miles in 3 hours. So how many miles are you driving in 1 hour? Now let's write our rate. 240 miles in 3 hours. But we know we need to find out how many miles in 1 hour. So we're going to divide. And we always divide by whatever the denominator is, because any number divided by itself gives us 1. Perfect, that's what we need. So if we do that down here, we do that up on top as well. Divide by 3, divide by 3, 240 divided by 3. Well, hopefully you're thinking 24 divided by 3 is 8. There's another 0, so I tack that 0 on. 80 miles per hour. They're going a little fast. Now, what if I had asked another question to go with this? What if I had asked also, how far do you travel in 5 hours? Well, as we recall from when we were doing our ratio tables, it's nice when you have a nice relationship between numbers. 240 and 3 and 5 hours, not a great relationship. We can't just multiply 3 by something to get 5, can we? But can we take our unit rate, multiply, and then figure out here, I have 80 miles in 1 hour. Now, how many miles do I travel in 5 hours? Well, 1 hour times 5 is going to give me the 5 hours. So if I multiply by 5 in the denominator, multiply by 5 in the numerator. 80 times 5, 400 miles. So we can take a rate, turn it into a unit rate, and then use that unit rate to find a whole lot of other rates as well. I just wanted to show you that in case anything comes up like that in, say, a homework assignment. Okay, now, let's take a look over here. 12 muffins cost $6.25. I'm going to step over here so I stay in the frame a little better. Now, so far in these, we've written whatever's first is listed first is what's first in our problem. Now, do we do muffins per cost? Like one muffin is, what cost, or do we do cost per muffin? Usually we talk about it as cost per muffin, or because the other way, it's not really one muffin, then it's muffins down to like 1 cent or $1, or that doesn't make sense because we don't buy partial muffins. We buy whole muffins. We buy 12 muffins, 1 muffin, whatever it is. So our cost is on top, and that's why I mentioned up here, cost is often the first thing. So our cost is on top, $6.25 for 12 muffins. But how much does 1 muffin cost? Well, we'll have to find out. 12 divided by what gives you 1? That's right, 12. So I'm going to divide my denominator by 12, which means I do the same thing on top. Now, if you want to take advantage of tools that are available to you, you may use your calculator. So I'm going to do that, and I'm going to do $6.25, whoops, not 62.5, 6.25, there we go. Going to divide it by 12, and I get a big, long decimal. Okay? I get 0.52083 repeating. Now, do we talk about money with that many decimal places? No. How many decimal places do we have to have? 2. So, anytime you're working with money, you're going to need to round. And so, we get to the 2 here. The 2 next to it is the 0. The 0 tells it to stay the same. So, we're going to say that it costs 52 cents per muffin. Now, I will mention that occasionally when you work with money, and we'll see some more examples of this in the future, if you round, you end up with the same dollar amount. Now, how do you decide which might be the better deal on something, which is the better cost? Then you look at the next decimal place. But we'll deal with that when that kind of issue arises. For now, though, I want us to look at one more example. 5/8 of an ounce per 1/4 of a pint. 1/4 of a pint. This tells us we're going to do the ounces first because it's saying per 1/4 of a pint. Why do I say point? So, first item, second item. But we want to figure out, okay, if we have 1/4 of a pint, well, how many ounces do you need for a whole pint? 1 pint, a unit rate. Unit implies 1. So we set up our fraction. 5/8 over 1/4. So 5/8 of an ounce over 1/4 of a pint. But our unit rate, our denominator is always 1. So we'll have 1 pint down here, but how many ounces do we need? Well, what do we do with 1/4 to get to 1? Well, we can either say we divide by 1/4, which is the same as multiplying by what? That's our multiplicative inverse. That's right, we multiply by 4. So sometimes we divide, a lot of times we divide, but we can also multiply. If we have a number smaller than 1, we're going to have to multiply to get it up there. Make it larger. So I multiply by 4. If I multiply by 4 in the denominator, I do the same thing over here. I multiply by 4. Now, to do a little bit of that work here, I'm just going to do it on the side. 5/8 times, our fraction's 4 over 1. Either cross cancel or just multiply across and reduce. Either one. 5 times 4 is 20. 8 times 1 is 8. Let's see, what goes into both of those? 4 does. So 20 reduces down to 5, and 8 reduces down to 2. So you have 5/2 of an ounce, or 2 1/2. You could also say 2 1/2 ounces per pint. These are the kinds of things that you're going to work on in your assignment today. You'll be given some quantities, you'll write the rate, and then you'll write the unit rate. Alrighty, thanks for watching.